What is up, car and tech fans? Welcome back to another garage tinkering video. I'm really looking forward to this one because I get to share with you a couple of major updates in our making an ultimate car gauge thing that we've been working on, with two significant points. Firstly, after making that T&C error and ordering the wrong ESP-32 chips for my PCBs, the replacements have arrived thanks to PCBWay, and I dare say they're working. We'll take a look at them first, and then we looked last week at how I feel that modern digital dashboard design is going in a lot of ways in the wrong direction, and there's an argument to move towards simplicity and minimalism as opposed to over the top and putting too much information that is distracting in front of you when you're driving a car. So I've designed a water temperature gauge, which is different to how water temperature gauges usually look in a car. So we're going to go through it, see how it works, why it's different, pop it in the car and see how it feels, and then we can all have a big old argument about whether it's good or trash. And I'm looking forward to hearing your opinions. But first, let's take a very quick look at the PCB that has arrived about 20 minutes ago. So here it is. And if you saw the last video about this, the only difference is that this one is N8R8. So this one has SD RAM in it, whereas the previous one that I ordered did not have SD RAM in it, which didn't allow me to create a large enough frame buffer to send to this 480 by 480 screen. Oh, spoiler alert. We're not going to do a full deep dive into this PCB today because we're going to look at it literally under a microscope next week and see how it's all put together. But for today, the important thing is that it works, the screen can be dimmed, and I can send quite clearly data to my LCDs. As always, I have to give a massive thanks to PCBWay for sorting this out for me. When they saw that I'd ordered them the wrong chip, they immediately got to rebuilding them for me with the correct ones. So hence why I've got the replacements quite so quickly. So thanks, as always, PCBWay, for sorting that out so quickly and getting them over to me. So if you are looking at having your own set of custom PCBs made, or you want to order some of these once I release it next week, you can follow the link in the description to get $5 off your first set of boards. But like I said, we'll deep dive more into that next week. This week is more about the redefinition or the simplification of a water gauge. A very, very simple, common use case that most people have in a car. So in order to understand why I think it needs to change from a user experience perspective, let's go take a look at both of my cars and how they do it in there. So we'll start off having a look inside my 350Z, and for everybody who likes to complain about it, yes, here in sunny old England, it should be 350Z. I should say it's Z, but I like the way Z sounds. 350Z. It's got a nice timbre. So I'm going to say Z. I'm a human. I can choose. Anyway, let's move on. When we look at the water gauge, we have very simply a needle with a range and then a naughty bit at the top, the overheating range. But what does any of it really mean? When I turn the power to ACC, it technically is showing the new value on the needle, whatever the temperature is, but it's not moving right now. And I know from having driven it for a while, it's not going to move for a bit. I don't know at what point or what temperature the needle actually starts to move. And that's kind of my argument for this is, what does that temperature gauge actually really tell me? Is it in between the bottom value and the top value is okay, but if I go onto the red, that's bad? What about low temperature? Can it be too low? Yes, temperatures can be too low in a car, but it really doesn't give me any tangible information. And if it is the case that between the bottom notch and the top notch is fine, then if it's in between that range, do I even need to know about it? Surely the only thing I care about when I'm driving around day to day is, does it go into the red? And if it doesn't go into the red, everything's cool, right? Next up, we're in my
2004 Honda Civic. It's the daily, it's very unassuming and has good mileage, but the story here is very much the same. When we give it power, we get the fuel meter and we get our temperature reading. But again, what does that temperature reading even mean? What's a good temperature on it? It's got like, I don't know, 20 little notches on the way up the scale. What do each one of those notches mean? What's a good value? When is it overheating? What's its ideal range? Is it just anywhere on the scale? I don't know. And if I don't know, someone who is like an expert in creating these things, what's a layman or an average person who drives a car who doesn't really care about cars supposed to think? How do they know what's good, what's ideal, what's a normal range? There's got to be a better way of doing this, and I think there is. So let me show you what I've done. To break it down, my argument against the standard water gauge is that it gives you too much information all the time, but it also doesn't give you enough information when you need it. Let's say you're an average person and you drive your car very averagely every day. You don't really know a lot about cars. You're tootling along and you look down and your water needle is at 75% up the arc, up the angle. And you think to yourself, I've not really seen it that high before. Is that bad? And that's an interesting question, because is that bad? Like, there's no standardized range. It's not that the bottom and the top of the arc is all the same. So then when they're home and they get on Google and go, my car needle gauge is at 75%, is that bad? Well, that's not really enough information. But if you were to say my water temperature or my coolant temperature is 95 degrees Celsius, is that bad? Then we know there's a tangible answer to that. Conversely to that, during that normal everyday driving, if I'm looking down and I see my fuel meter there, which is fine, why do I really need to see my water temperature at all? If I'm just doing regular daily driving and everything in the car is all okay and my temperatures are all fine and nothing's overheating or nothing's underheating, do I need to see it at all? I don't think you do. I think we have too much information, especially on modern digital dashboards. And if you haven't seen my video on digital dashboards just being too much, you can check it out. I'll link it up here. But I think we can remove a lot of information and still have it be more useful. Whilst a few of us were discussing this idea over on my Discord, and if you want to join that, there is a link in the description. One of my moderators and friends of the channel, Fletch, put up a quote by French writer Antoine de Saint-Exupéry that I think fits this really well, which is, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And really, that's what we've done here. We've made it so that there's nothing left to take away. So let me show you how it works, and I'll talk you through the thought process behind it. So this is the gauge as it is when you start up the car. Not a lot to see because we start with nothing. And though you probably can't see it in this light, it did fade in a nice and pleasing way. So let's simulate some data coming from the car. So this ESP32 is just going to represent some data being sent to this board. When it's in the actual car, we will be using hardwired CAN bus straight into the board. But for the purposes of this demonstration, we're using ESP-NOW. So let's take a look at like a kind of simulation. When this plugs in, it's going to be representing what would happen when you turn your key to the ACC position. So power is on, but you've not actually started the car up. I'm going to boot this up. It'll start sending data, and this is what we'd see when the ACC is on, but the car hasn't been started, the engine's not running. And it would usually just sit at a value to show what the coolant temperature is, but this is counting up because of this simulation that we're running. When it gets to 65, that's when we turn the car on. So when the car is actually running and the temperature is actually warming up, we'll get this little warming up, which shows me that the car is not at a good temperature currently. With something like a 350C, you don't want to drive it too hard until the water and the oil temperature is within a good range. And that range starts at 75. So after we pass 75, it gives me a little visual pull.
to say, look your eyes over here. And that green spinner does that. It pulls your attention to it. In fact, let's just look at that again. I'll reset this and then reset this. So if you can imagine, it's like ticking away, and the temperature is slowly increasing as the car does. But you don't need to look at this all the time. All you need to know is my car ready to be like driven enthusiastically? And it so happens that the parameters I've set up for this are for my 350Z, and it's when the coolant temperature is above 75 degrees. There are obviously other parameters as well, but for the sake of this argument, we'll just look at that one value. So when this goes over 75 degrees, it does something to draw my attention to it, and then says, ready. So it's ready to be driven. And then at that point, it all goes away, because at this point, I don't need to know what that temperature is anymore. So long as it's between my lower limit, which I've set at 75 degrees Celsius, and my upper limit, which again, for the sake of just this demonstration, I've set at 105 degrees Celsius. As long as it's between those two limits, it doesn't matter. Everything else is fine. I don't need to see it. I can use this display for something else, and that can just monitor itself in the background up until such a point that it is outside of that range. And if it's outside of that range, then this will happen. And I might need to just wait a minute, because this is still ticking up every 2 seconds. It goes up 1 degree until we hit the upper limit of our range. There we go. After 105 degrees, my temperature is now too hot. So it does another little spinner just to draw my attention to it, and is now constantly telling me it's too hot. So I might start to drive more sensibly, or I might pull over to let the car cool down. And then again, as the temperature comes down, once it gets within nominal range, under 105, it again tells me everything is ready to go and disappears. Because again, I'm back in a state where I don't need to see it. It's not overheating anymore. So it's fine just for it to go away. Now there is one other condition, which is rare. I don't think I've ever seen it in a car that I've owned in my entire life. But once it's reached nominal temperature, there's a chance that the coolant temperature could come too low and go below my lower threshold, which again is 75 degrees. So at the point where this gets too low, it will similarly alert me that it's too cold. So we just wait for that to kick in. Right on time. So it's now too cold. And this is going to keep coming down and down until it hits 55 degrees. And at 55 degrees, it's going to simulate what I want to do when I turn the car off, which is go into kind of a mode that analyzes what the drive was like, and it shows me some information about what the maximum temperature we reached was over the course of the drive to see, did I overheat at any point in time? So when we get to 55, it goes to the maximum temp mode. So the maximum temperature we hit over the course of this drive was 110 degrees. And this is the screen it goes to when you turn the car off. It flicks to this and it stays here until you remove your key, at which point the screen obviously all goes off. Obviously, none of this is majorly complex from a design or a development perspective. It's just honestly a lot of if statements that catch certain conditions as we move between statuses, which is what I've called them. The real crux of it, though, is that it's blank for probably most of the driving experience. And honestly, I don't know, because I haven't got it in the car and tried using it every day, if it's too weird, if it feels odd not having that gauge showing. It might be the case in practice that I want it to get to the ready state and then just continue to show ready so that I can keep a little look at it. But really, why do I need to keep a little look at it? Is it something that's just historically ingrained because I'm used to it, and it's therefore become a habit to look at it when driving? And if it is a habit, we can surely unlearn it. Now, it's all well and good it sitting here with demo data being thrown at it, but how does it actually feel
when we get out into the car. Let's take it outside and take with us our trusty little canvas data distributor that we got from Mr. DIY, friend of the channel. Thank you very much for sending me another one of these. It's been very useful. These are awesome. They plug straight into your OBD2 port and allow you to basically take all of your canvas data, filter through it, and then distribute it over ESP-NOW, which is what we're using during the prototyping stages of this. Like I say, in the final version, it will be running off a hardware canvas, but for now, ESP-NOW is a great way of doing it and just checking that we've got all the right data points. Let's go pop it in the car and see what it actually feels like sort of in place. So back in the car, we'll start by putting the OBD2 distributor in. Just slots straight into the OBD2 port, and that is now good to go. And just for test purposes, we'll plug the PCB into the USB slot. That is going to present an issue because when I go from the ACC power to the actual power on, the power will cut, so the board will reset. So that nice animation you usually get between the two will probably skip, but it won't be a problem in the final build. Also put the board like kind of where it's going to live in its final iteration, just so we can get an idea of if it actually catches my attention or not. So let's put on the power and hopefully we get the current coolant reading. It's currently like 20 something degrees outside, so I'm expecting it to be in that kind of range. Let's give it a go. Key in, turning to ACC. There we go. Oh, fades in. So 33 degrees, that makes sense. It's, like I say, mid-20s out, so it's probably the right kind of level. So that means looks like I'm getting the coolant temperature correctly. It's not going up or down, which makes sense. It's just, you know, sitting at 33. It doesn't say warming up because the car's not on. It's not warming up, it's just sitting. So let's turn the car on. And there you go, as I thought, it goes off and it will restart, but there we go, warming up. Now it now knows the difference, and immediately the temperature starts to rise. So it looks like it's correctly seeing that the temperature is going up. It looks like I've got an error somewhere to do with the code and it's filtering that degrees C. So I need to fix that, but inherently speaking, it is working and like increasing the temperature. But my argument is that I shouldn't need to look at this thing all the time. Does it just grab my attention when it's ready? So in order to test that, we're going to like see what I see and then see if he like grabs your attention in the corner of your eye when it gets to the correct temperature. But I've got to give it a sec because it's going to take a few minutes to get up to 75. We're currently at 48. And as it warms up, it's interesting to know that this one has gone all the way up from 33 degrees, which it started, to 56. And this one in the middle here has done nothing. It's not shown us any difference. Now I've got a feeling that this gauge is all kooky anyway, because literally everything on this is miles out. But yeah, it's not moved at all. And we're almost at 60 degrees. As that magic number also approaches, I have realized that the text I've made a little bit too dark. You probably can't see it on video, but I can read 70, 71 as it is now, absolutely fine. But the warming up below it and the icon above, I can see, but barely. So I just need to make them all a little bit whiter. Okay, 74. Even with this terrible lighting, if you were looking forwards, would it grab your attention? It did for me, but I don't know if it would capture on video. Now it's gone off because it's now within nominal range and I don't need to see it anymore. So that gauge is now free to be used for something else. And interestingly, this one still hasn't moved off the bottom. So what is this range? I'm now at the bottom of ideal. So why is that not moved? It goes to show that, you know, often these gauges just can't be trusted to show anything. But like I said, this one is now off. And how high is it going to get? I don't know. We can find out though, because when I switch the car off, it should come back up and show me what the maximum temperature it reached was. There you go. You can't really see it. 78 degrees. So that's the highest it reached, was 78. So in a real world application, there are some things that I do want to consider. Like I say, the text isn't quite bright enough, so it doesn't grab me quite as much. Plus, I could see the swirl perfectly well out of the corner of my eye, but again, could be brighter and could be a little bit bigger. So again, we can just tweak the values of that in order to make things a little bit more prominent so that they actually do their job. But as far as kind of like taking away information that you need, I don't think we have. I think we've actually offered more information that's more valuable and can be understood by a greater number of people, whether car enthusiasts or not. For those interested, let's go take a little peep at the code and how it works. The crux of the code is really made up of two parts. The canvas data distributor, which, like I say, isn't going to be used in the final iteration. So we'll just like skim through that, but also the screen itself. Step one was identifying all of the parts that I needed that were coming out of Canvas, and we did that with SavvyCAN. Typically, when I boot up my SavvyCAN, I've got this file from an old drive that I did in my 350, and it shows all of the IDs of the different CAN IDs, all the different stuff that was available on it. Because I've worked on it before, I knew where the ID was. So it's this hexadecimal 60D, and it's these two bits here. This one here that never changes, that's the first step on the turn of the key. Then this one coming on is ACC power. So I can use that to sense whether or not ACC power is on. Also, I know that 23D, when we start to look at some of this and scroll across, you can see this red one going all the way up and down. Byte 3 together with this grey one at the bottom, byte 4, make up the RPM. So I was just able to also dig into that and go, is RPM 0? Because if RPM 0, the car is not running. If it's not 0, it's running. Simple. The code that is in the distributor itself is pretty simple. I will make both this and the code for the screen available to download from a repo, which will be in the description. So if you want to grab it and have a play with it yourself, you can do. It is prototype code. It is not finished. It is not production ready, but you're welcome to have a look at it. The only thing that really matters here is I've set up this MAC address for the receiver, which is hidden in my secrets here. You don't need to know what the MAC address is, but you put your own device's MAC address in there. I've got car started as a flag, and then the water temperature, which I'm sending through to this levels gauge, as it's called. And then at the very bottom, if we go into the loop, we've got this CAN reader. So this is processing all the different CAN IDs. Basically, we check every CAN message that's sent, and there's a lot. There's often 10 or 20 a second per ID that come through. So there's thousands of these messages, and we just filter them by their ID. So like I said, the one for the power switch is 60D, and the one for the coolant temperature is 551. So we just pass that into the correct function. So in this case, coolant temperature, I just made some notes about which byte and whatnot it is. So it's, yeah, a specific byte 0. And the way that it's done on this car is we take byte 0's value and minus 40, which allows us to go down to minus 40 degrees for coolant temperature. And then we just set this levels data object to have that data value, and then we just distribute it with ESP-NOW every X amount of time. There's a task that runs here, send levels, and this runs at 2 hertz, so twice a second. Every 500 milliseconds, it sends a new update of that data to the screen. So all you really need to know, if you want to dig into this more, like I say, you can download it from down below. The screen itself, considering how little it actually does, is probably right now both under and over engineered. I probably made it too complex for how it needs to actually be, but I'm trying to think 10 steps ahead for when I roll this out into other gauges and future proofing. So what it basically does is it has a variety of states, and these are the states: non, warming up, ready, too hot, too cold, analysis, and hide. So when the car first starts up, it has no state. It's just showing the value and the symbol. So it's in non-status. So these are the statuses. Then it's got a warming up status. So when it's warming up, ready when it reaches it, too hot and too cold. Analysis is the final state that it shows when you're turning the power off. And hide is when everything goes away. And then we've got different types of alert, which is the spinner around the outside. These are just managed separately because they're on an overlay layer as opposed to being in an LVGL standard, screen layer. And the reason this is just done like this is for easy management. So the idea is that I can just send set status to ready and the ready status fires. But the reason this has become over-engineered is because of one little fact, and it's the fact that I am anal when it comes to little pretty details. So the fact that when you move between statuses, the status message fades out and then a new one fades in. And similarly, when the entire thing fades out, everything fades out and it all fades in. Managing those little fade out to fade in timings and making sure only the appropriate things, like we've got the icon, the value in the message, making sure the appropriate ones fade in and out, was just a little bit of a job of catching certain things. So if I go to the function that is called every time new data comes in from ESP-NOW, which is this update values. So we start just by looking if the water temperature that's been passed is greater than the maximum temperature that we've saved. So we're saving the maximum temperature. If so, update it so the maximum temperature is now the new maximum temperature. It just means it keeps going up, but then if the temperature comes down, it stores the maximum value so that at the end of our drive, we can see what the max was. And then, like I say, it's just a bunch of like little if statements that check if certain conditions have happened. Because, like I say, when we've got all three of the values hidden in hide mode, we need to show all of them again. But if we're going not into hide mode and we're going in between two modes that are not hide mode, then it needs to just hide the message and then just bring the message back. So there's all these like little catches based on the statuses that is switching between. There's probably a more elegant way of doing this, but I built this entire application in about 90 minutes this morning, so I've not refined it. We'll get there when I make this a bit more production ready. But like I say, we've got a bunch of catches. So ignition on, when we first starting up the application, ignition on is switched to off, which means the ignition has never been on. So we say, has the car ever been started? Is it ever not been started? If so, it starts up in this non-status. So it's just the icon and the value, and it doesn't have a message. But if it ever comes back to the point where the car is on but not running, so, we switch the ignition off, ignition on will mean it has been on. So when we come back, it means it doesn't go back to the non-state, it goes back to the analysis state. Then we have some tests to see whether or not things are within the limits that we've defined, and at the top we've just got a bunch of static things which make the management a bit easier. So these are the various flags. Has a button been pressed? We're not using those, let's not worry about that. But has the initial fade in where the screen fades up completed? Has the first load ever happened? Is data ready? So has new data been passed in from ESP-NOW? And is the status currently changing? Because there was a catch, because the animation takes 2 seconds. If a new update comes in, which it does, it happens every half a second, it could sometimes trip up the animation because of the priorities. So whilst an animation's happening, nothing else can affect that animation. So we just have a blocker that stops it firing new status changes if a status change is already underway. Has temperature ever been reached? Is a little check. See if it's ever actually got into the ready range, because if it's got into the ready range and then it's come out of the ready range too low, that means the temperatures come down outside of the ready range. But if it hasn't ever reached the ready range, then it's still warming up. So it's, again, just to check between those two things. So we set the various statuses, so analysis, non, too hot, ready, too cold, warming up, or non, to see what status we need to set based on what's happening with the car. And then only do the updates to the value, so the running value, if the analysis mode isn't on, because once it gets to the end and we've turned the car off and it's showing the maximum temperature that we reached, it's still sending the current temperature at it, but we want to ignore that because we're in analysis mode. So again, a couple of little just checks. So then we've got a set status, and again, just little catches. If the statuses are the same, we ignore it, so we catch that exception. Or if we're trying to go to ready, but the current status is hide, we don't want to do that. And then this if status changes, so this will only run if the status isn't already changing. If it is already changing, it waits until the future iteration, and then it'll do the change that it needs to do. So like, say it's come into ready and it's gone straight back out, it will finish the ready animation and then it'll go back out to the too hot animation or whatever. It'll do it afterwards rather than, breaking one on top of the other. They only take 2 seconds, so, it doesn't need to be that time critical. But the key thing about all of this function is when we're changing between statuses, for pretty much all of them, we fade the message, the little text underneath, out, and then fade in a new one. So if we go from warming up to ready, that fades out and fades in. But if we're going from warming up status and it hasn't reached temperature, but then we turn the car off, it needs to go from warming up to the finished status. So the icon can stay, but the value and the message need to fade out. So, I'm not gonna dig through tons of this code. It's not hugely complex or difficult, really. Like I say, it's just a bunch of if statements that then start up timers. So, we set the status, which fades everything out, and then it starts a new timer, which it needs to do in order to fade everything in after the fade out's happened. And again, make sure that one thing doesn't happen before another. If you want to have a look at this and dig it into yourself, like I say, the link is in the description, but I'm not going to go through this too much for now. We'll save that for another day when we actually start to productionize this a bit more and do things like, setting those ranges, that max minimum. You should be able to just log on to it with your phone, right? And go, I want my minimum value to be 75, or I want my minimum value to be 90. I don't want it to, think that it's ready until it's hit a higher temperature. We're going to do all that, and that's something that we're going to integrate into it. This is how we're going to make the ultimate gauges. Really, I personally think that the most interesting thing to come out of this part of this process is just thinking about another way of doing something that has been ingrained for 100 years. I'm obviously not the first person to ever put a digital representation of a temperature onto a digital gauge. It would be ludicrous to claim otherwise, but I don't think I've ever seen one where it disappears and it only actually shows you information if something's wrong. Yes, that exists on dashboards in, your check engine light and your seatbelt light. They only come on if something's wrong. But what we're trying to do is expand that out and expand on that principle of only actually giving you, the driver, the information that you require, if that. I think that when I take this to the next step, when we've got the two outer gauges doing basically this process, showing information that's contextual and when it's needed, but using the middle one to show information permanently. Spoiler alert, this is a little bit of the design of something that's coming over the next couple of weeks. Pertinent information in the middle. Everything else, the information comes and goes. I think is an interesting new way of looking at digital gauges and how we actually present information and use them. I'll be very interested to hear what you think about this one. Some of you are going to hate it. I know you are, and you're going to have very strong arguments for it, but that's why these things are going to be adjustable. You can keep those values on if you want. But give me your opinions. Tell me what you think. Obviously, like I say, this is a 90-minute prototype. This isn't something that's production ready. But like I've said before, we're taking this on an MVP approach, a minimum viable product. So let's get something in that works and nice, but simple, and we'll build on it and see if we need to add anything or if having nothing is fine. I've got a feeling it's going to be good. I obviously need to do a few little tweaks and changes to this. That degrees C symbol coming and going is a bug. I just need to fix that. And then, like I said, whilst I was in the car, make some tweaks to the colors, make them a little bit brighter and make that spinner a little bit more prominent. But otherwise, I think this is a good starting point. I can't wait to hear what you think. And then I can't wait next week
to delve down into these PCBs a bit more, show you what they can do and why they're going to be so good for what we're building on this channel going forwards. I think you'll start to really get everything. Then we can build on top of that and see how we iterate it out with the ESP32P4s and these big old 3.4-inch screens. That's going to be pretty cool. Anyway, if nothing else, if you are working on a dashboard design, I hope this has made you think about the fact that you don't necessarily need to be beholden to what exists. You can try something new and maybe it'll work, maybe it won't. But there's never any harm in trying. That's the big takeaway from this. Don't be afraid to just give something weird and wonderful a go to see if it works. If it does, great. Maybe you're onto something. If it doesn't, you can always fall back on the stuff that's been done for literally 100 years. Anyway, whatever you do with the rest of your day, folks, have a wicked one, and I'll see you in the next video. Same time, Wednesday, 2 p.m. Take it easy, peeps. Bye-bye.